Welcome back to physics. And now that we've spoken about momentum, we're going to move into talking about change in momentum, which does have a special word called impulse.
So, definition for impulse, change in momentum, or in formula forms it would be delta P. Remember, delta is a change in its final minus initial. So this would be final momentum minus initial momentum.
So let's write that out. So we're doing final momentum minus initial momentum.
So when does this happen? You have a car on a road that either speeds up or slows down. How could that car change its momentum? The mass of the car doesn't change. So what would have to change in order for the car's momentum to change? Its velocity.
So remember that momentum is mass times velocity. So when we say a change in momentum, we're saying a change in mass times velocity. So that could be a change in mass times a change in velocity. But if our mass isn't changing, which it typically doesn't, then we can ignore that change. Okay? This triangle symbol, just to refresh your memories from math, is delta and means change. So just keep that in your head.
So, like she said, most of the times mass doesn't change. There are going to be a few occasions where we have a weird situation where a cart is rolling across the table and we all of a sudden drop a mass into it. Well, the momentum will change. Depending on what's going on, sometimes the momentum does not change, but we'll talk more about that when we get into conservation of momentum. Here, we're just talking about what happens when momentum does change. Well, what would actually have to happen for a car on a road to change its momentum? Yes, its velocity would change, but how would that happen? Let's say you're doing 60 miles an hour on 347, because that's what everybody does, and there's a red light. What do? You apply the brakes. When you apply the brakes apply a force to the car, and that force slows down the car in a certain amount of time to stop. So impulse also has another formula. That other formula is force times time.
So on your reference table, it's written like this.
Now this is a very confusing formula for a lot of people because there's a lot of stuff in it. It's got two different equal signs. But that's not really that complicated. It just means that J, which is impulse, is equal to either force times time or your change in momentum, and it's equal to both at the same time.
So when you go to use this equation, you're only going to use the parts that you need. So if you are reading through a problem and let's say that it's just talking about the car and it has the mass of the car and the initial speed and the final speed of the car and it tells you nothing about force or time, you might not use this middle piece of your equation.
And that's okay.
You might just say, okay, delta P, which I know delta means final minus initial, and that's where I'm going to go. That's fine. Or they might tell you something about all of those changes and you're trying to figure out how much force you applied. You might not need this J side. That's fine too. So you're really going to look at what do you actually have to figure out which parts of the equation do you need.
Let's talk about the units one more time really quickly. So your impulse, which is J, is equal to force times time, and it's also equal to change in momentum. So let's talk about the first very basic and simple unit for your impulse. It would be change in momentum. Well, momentum's units are kilograms times meters per second. You would be subtracting kilograms times meters per second minus kilograms meters per second. They don't cancel because you're not dividing them, so the unit for J is kilograms times meters per second because it's a change in momentum. But we also said it's equal to force times time. So then the question is, what's the unit for force? It's newtons. What's the unit for time? Seconds. So another unit for impulse is newton seconds, or newtons times seconds. Now, one of my favorite questions of all time is a question about a ball and a baseball bat. So you take a baseball, you throw it at somebody, this person with the bat swings and hits the ball, and the question will say, the bat implied an impulse of, let's say, 1,000 newton seconds to the ball. What's the change in momentum of the ball? She's going to answer. Ready, go.
So that's one of those questions where, to be honest, they're really just testing your reading comprehension and your knowledge of definitions. Okay, so we had, I forget the number, 1,000 Newton seconds of impulse, and we're being asked for our change in momentum. All they're really asking you to do is to think about the fact that impulse equals change in momentum. The definition of impulse is change in momentum. So they're really just saying, can you tell me that number? Do you know that those two phrases mean the same thing? And since impulse and change in momentum are the same, your change in momentum would be 1,000 kilogram meters per second. Now, could you write it as 1,000 Newton second? Yeah. Those units are the same. Right? And if you go back to thinking about what the definition of a Newton is, you can prove that to yourself. They are the exact same unit, does not matter which one you use. But there are some of those questions that there's all this tons of information in there, and it's really just, do you know your definitions?
Now that baseball bat and baseball question could go further and say, what is the force applied to the baseball by the bat? Or the reverse, what is the force applied to the bat by the baseball? Because Newton's third law says they're the same. They would have to give you a time. So if they said the ball and bat are in contact for 0.3 seconds, well, you know that J, which is 1,000, would be equal to force times time. So if I say the time is 3 seconds, divide the time over to the other side, so 1,000 divided by 0.3, and you get some crazy number. We use calculators for this.
$3,333 newtons.
That's a lot of newtons for a small little ball. Now, that's the reason why the momentum changes so quickly on the ball, and the ball goes flying off in the opposite direction. I don't know if that's enough for a home run. I haven't done that math yet.
So now the question becomes, what would happen if that baseball was in contact with the bat for a longer amount of time? What would happen to your force?
Well, here, this relationship is always going to be the same. So J is equal to force times delta T. If the time goes up and the J has to stay the same, the force would have to go down. If the time goes down and the J stays the same, the force has to increase. This is the reason why airbags in cars save people's lives. No matter what happens in a car, your change in momentum in the car accident is always going to be the same. As long as you start at the same amount of velocity and end at zero, because you're crashing into something, your J will always be the same. Why? Because it's equal to your change in momentum. Your momentum is always going from some number to zero. So, an airbag will increase the amount of time it takes for you to slow down. You squish into it. That increases the time, which decreases the force to make your J stay the same. What happens if there's no airbag? There's no airbag, you go crashing into the windshield or you go crashing into the dashboard, the time becomes very low, the force becomes very high, and you die.
Therefore, make sure you have good airbags and your seatbelts, because the seatbelt does that same thing. It's pushing back on you and making it takes up a lot more of that force. Okay? So that is where all of that comes into play with how long you're in contact with something and how much force it's actually providing to you.
So even though momentum started as a very easy topic, it was just mass times velocity, you can see how quickly it becomes kind of confusing because we're going to throw a whole bunch of numbers at you and be like, figure this out, please.
Okay, so make sure that you are understanding what the different variables are. Okay, that is one of the hardest parts because this is the first topic where these variables make no sense. Momentum being P, impulse being J, they make no sense. So make sure you're really comfortable with what they are and that you understand these definitions, that impulse is change in momentum. That's going to be the key to solving a lot of questions.
Come to Extra Help if you need it, and good luck. Have a great night.